All right, so this is the review to get us going on the 2 gram lab. All right, that's about the week and a half that we're going to spend on this lab. This is to kind of refresh ourselves on what we have done all year. It's not just the second semester, it's stuff from the whole entire year of chemistry. So we're going to review on your blue note sheet. It follows throughout the PowerPoint. All right, so make sure you fill that in. That's going to be your notes. That's the thing you're going to reference back to throughout the day. You have, then you're going to work on a worksheet when you're, or a little small packet with all these different concepts in it. So make sure you take the notes so that you know what you're doing when you go back. Okay. Um, so first off, the first concept that we're going to look at is significant figures. All right, and they are meaningful numbers in a measurement. They are telling us what is the instrument that we're using, what is it marked off in? What is the scale? What is it telling us? Okay, so it's all meaningful numbers. So it's all the numbers, significant figures include the numbers that are certain. So what it's marked off, and we know that for certain, plus one that is estimated. So it's telling us that it's about maybe 0.5. All right, it all depends on what it's marked off in. So if you look at this graduated cylinder here on the left, you notice that it's marked off in ones. So if we look at right where this arrow is, all right, we know that it's too much if we include all of these numbers afterwards. All right, if we just said 12 though, that's not enough. Right? Even if it was right on that line where it said 12, you cannot just put 12. You have to put 12.3 or 12.5. All right? You have to tell me that's marked off in ones and then it goes to the 10th place. All right? So that's what significant figures are. They're including numbers that we know for certain. We know for certain it's 12. We estimated one more, so we said it was zero point 0.3. Okay, and it's telling us how this graduated cylinder was marked off. All right, when you are using a digital balance, you must include all of the numbers on that digital balance. All right, it is already giving us that significant figures. It is telling us that last place value is telling us it's estimated. All right, so that's why the 100th place value on your balance, even if it's like going back and forth a little bit, it's just an estimation. All right, so include all of the numbers on your balance. All right. Now, when we get to multiplying and dividing, which we are going to have to do in this lab, um, you count all the significant figures in the measurements. All right. The second bullet point, so right here, this is going to be very key. Ignore conversion factors and constants. So if you have a conversion factor saying, 1 mole equals 35.5 grams, that's a conversion factor. You do not include that in your when you're counting significant figures. Okay? To count them, you're going to use the saying dot right, not left. So if there's a dot, a decimal, you count to the right. Okay, if there's not, you count to the left, and you start counting when you come to the first non-zero number. All right, so if we look at this very first problem, 2,400, there is no decimal point in there, so we're going to move to the left, and these first two zeros do not count. All right, we have not hit a non-zero number yet. All right, so they do not count in our significant figures, so that's why we have two significant figures. All right, in the next one, we have a decimal point. So we are going to move, awesome. We are going to move, maybe, maybe not. We are going to move to the right um, so that we don't start counting until we hit that first non-zero number. So those first zeros do not count. All right, so it's 1, we start with the 2, and so it's 1, 2, 3. The 2, 4, and then that last 0, because once you start counting, you have to count all the way to the end. All right, and the last one, there's a decimal point, but we hit a non-zero number right away, so we start counting, we count all the way to the end. All right, so when we're multiplying and dividing, you're going to use the least number of significant figures and then round your final answer, okay? Do not round until the very end. So do not round intermediate calculations. Round at the very end and count those significant figures. All right, and you're going to do some problems with that um, in a little bit. All right. The next concept is called the law of conservation of mass. All right. It talks about what balanced chemical equations, but what also is very key with the law of conservation of mass is that the mass at the beginning, the reactants, must equal the mass of the products at the end. And this is going to be the number one way to check to see, am I doing my calculations right with my lab? This is going to be huge. And there's examples in your practice packet, all right? And this is huge, okay? The mass of the reactants must equal the mass of the products, all right? And you'll see how to do that. It's not hard. You just add up all the masses of the reactants, the things they're starting with, all right? And it must have the same amount of mass as the products, all right? So also, you talk about balancing equations, all right? You have to have the same number of atoms on the left side as you do the right side. So here we have a practice problem, all right? In water, iron 3 chloride reacts with sodium hydroxide, producing solid iron 3 hydroxide and sodium chloride. All right, so it's a double replacement reaction. In the 2-gram lab, everything that we're looking at is double replacement. All right, and so we need to figure out how to balance these. And remember, polyatomics, they're the same on both sides. They can count as one single unit. If there's not, so if it didn't have OH on the right side in the products, then you had to separate the oxygen and hydrogen. But it's the same thing on both sides, so we can count them up. All right, so count up how many there are on both sides. We look at, okay, well, what's not balanced yet? We have the chlorine and the hydroxide. And we can see that, ooh, 3 chlorines on the left, only 1 on the right. So we're going to have to put a 3 here to balance it out. All right. And so we put a 3 there. Always, if you put a 3, put it in as your coefficient first, and then change your numbers, and always change it afterwards. Okay. And since we need 3 chlorines, we put 3 in front. It also changes the sodium. All right. So now sodium and hydroxide are not balanced. There's 3 on the right, only 1 on the left. So we're going to put a 3 out here. Oh, well, guess what? Everything is balanced. All right, so make sure you, when you put your coefficients out front, that coefficient goes through everything in that whole entire compound. All right, and once you have written your double replacement reaction, all right, you look up the charges crisscross when you need to. All right, but once you've written that, that can't change. You cannot stick a 3 over here on that chlorine. All right, you have to put a 3 in the front. All right, so tips on how to redo this. Always update your element count. So once you put a coefficient in, always update that element count. All right, balance single elements last. All right, because you can change. You can put whatever coefficient in front that you need to. Treat polyatomics as a single unit. If their form does not change during the reaction. So if they're the same on both sides, treat them as one thing. Okay. Multiply odd number of atoms by 2 to make them even. All right, even numbers cannot be made odd. All right, if that makes sense, you can't cut something in half or use the least common multiple. So like if something's 3 and something's 2, multiply everything to get that least common multiple. All right, and then the last part, coefficients must represent the simplest ratio. So you get everything written in your balance equation. If you can divide 2 by all of it, divide everything by 2. You want the simplest ratio possible. Okay? So double replacement reactions. We actually talked about this again last unit with solutions. All right? So those positive cations, the A and the B, are going to switch partners. All right? And again, you're going to switch partners and you're going to write down, okay, what is the charge on B? What's the charge on X? Do they have to be crisscrossed to balance out those charges? Yes, no, maybe, okay? Same with A and Y, all right? Then you're going to look on your solubility table, okay? And I have them sitting up front if you need them. They're in your notes that you didn't turn in. They're also on page 920 in your book, all right? And AQ means aqueous, okay? So it's still dissolved. The one that's soluble, that has an S, that's insoluble in water, so you'll still see a solid, okay? So you're going to look at, this is what we're doing in our lab. All right, you will have to have a double replacement reaction. All right, so just remember that those positive cations are switching partners. All right, so for solubility, you will always start with two aqueous solutions. So that means that you will have to dissolve solids in water. All right, and so you're going to take your two liquids and you're going to pour one into the other. Okay, and when you pour one into the other, you are going to see that one becomes a solid, the other stays as an aqueous solution. And that solid, that's what you're going to want to get 2 grams out of. Okay? And so it'll form that precipitate, that solid, all right? And you're going to then filter it and get that solid out by itself. All right? So solubility table, you guys know how to use this now, but remember you look up whatever your cation is, whatever your anion is, find it where they meet. If it says S, it is a solid. If it's AQ, that means it dissolves in water. Okay? Hydrates, we have not talked about these a whole lot. We've talked about them a little bit, but not a lot. Okay, so it is a compound that has a specific number of water molecules that's bound to it. Okay, so bound, that does not mean that it is bonded. All right, it's just there, it's kind of attached to it. Just like in solvation, where the water pulls apart that sodium ions or the chlorine ions when it dissolves salt, that's kind of the same thing. It's just, it's bounded to, it's around it. Okay, so the number of water molecules associated with each of the following with each of the formula units, it is written by a dot separates them. That dot does not represent multiplication. Okay, just means bounded to it. All right, so here we have sodium carbonate, and then we have 10 water, so it's decahydrate. And so those prefixes that are in the front, that's going to tell you the exact amount, how many waters are bounded to it. Okay, so 1 mole of sodium carbonate, there's 10 moles of water bounded to it. All right, so we're going to look at a few more. Anhydrous means without water. All right, so when these hydrates decompose, the water just falls off. All right, and so with the sodium carbonate decahydrate, this is hydrated. This has become an anhydrous salt. Okay, so it means without water and then the water by itself. All right, so what's important about this is because a lot of your products are going to be have this in it. All right, but we need to figure out, how do we figure out the molar mass for that? So all you do is you look up, okay, here's the formula. Iron 3-phosphate tetrahydrate. All right, so this is my iron phosphate, and this is the water. So you figure out, okay, well, what is the molar mass of iron phosphate? You guys know how to do that. Look it up in your periodic table. Go from there. Okay, water, you know, is 18 grams per mole. All right, then you just add them together. So I have 1 iron 3-phosphate, all right, plus, well, I have 4 water, so I'm going to take 4 times my 18, and then add that to my iron phosphate. Okay, so you, again, this does not, that dot does not represent multiplication. Just add them together. All right, so figure out what the iron 3-phosphate plus the 4 waters, that would be your molar mass of the whole entire compound. Okay, all right, if you have questions on that, please let me know. I'll be back on Wednesday, so let me know if you have any questions on those. Please try them out. If all else fails, you have to change your answer, that's fine. All right, but please try this out. Try to figure it out, what it would be. Okay. Our last major topic deals with stoichiometry, which is all your favorite things. Okay, so first off, a conversion factor. Remember, it's just a mathematical expression that relates one fact to another fact. All right, so when we were looking at conversion factors in stoichiometry, we were usually looking at one substance compared to another substance. Okay, we can express them as fractions, so they're equal to 1. Because these are equal to each other, we can express them one over the other. And it doesn't matter which way you write it, that still means the same thing. And that's why we can do 1, grams over 1 mole, or 1 mole over a certain amount of grams. Okay? So when we're doing dimensional analysis problem, because you're going to have to do that, you are going to relate your known units to unknown units. What are we trying to solve for? What are we starting with? What are we trying to get to? And what we put in that middle is called our conversion factor. And we'll always put what we know on the bottom. All right? What we don't know has to be at the top because we want to end up with that. So our known units are actually going to cancel out. All right? So we're left in that unknown units on top. All right? Because we want that to be what we're trying to solve for. Okay? So molar mass relates to the atomic mass of an element. You guys know this. And it's to 1 mole. Always it's 1 mole of that element. Okay? So again, it doesn't matter which way we express it. All right? But that the molar mass part is one that is just within the same compound. So if I'm comparing sodium chloride to grams of sodium chloride to moles of sodium chloride, right? Whereas stoichiometry, this is where we're going to look at maybe if I'm starting, how many grams of sodium will I need to make so many grams of sodium chloride? Okay, so stoichiometry looks at one element and how is it related to a different compound. Okay, so mole ratios can be expressed as conversion factors. All right, and it relates moles of one substance in the balanced chemical equation to the moles of another substance. They are different substances. Right, that's how you know when you need to use a mole ratio. Am I starting with one substance and I'm going to a different substance? Okay, if I'm staying within the same thing, then I don't need to use a mole ratio. Then I'm just going to figure out grams to moles. Perfect, I use its molar mass. But going from 1 moles of one substance to moles of another substance is when you use your mole ratio. Okay, and that's what stoichiometry is all about. All right, so if we look at this balanced equation, we know the mole ratio of aluminum to aluminum oxide is 4 to 2. Okay, so if I'm starting with moles of aluminum oxide and I want to go to moles of aluminum, this would be my conversion factor. Okay, I would plug that in to what I am looking at. All right, and again, we are not going to simplify these conversion factors. Even though we could, we're not going to. Okay, all right, with stoichiometry, you always start with moles of A. What am I given in my problem? All right, trying to get to moles of B. Okay, so remember, whatever I'm given has to always go on the bottom. Whatever I'm trying to get to is going to be on top. All right, so and you get this from your balanced chemical equation. Now we can put gram molar mass on either side of this if we're looking at grams, but this is the key part of stoichiometry. All right, and it's not knowing how many steps to do, but it's looking at what am I starting with, what am I trying to get to. Okay, so this is the end of the review notes. You have now a review worksheet to work on, and I'm going to be collecting both of these, okay, on Wednesday. I'm collecting the notes, and we're going to look at the packets, and then I'm going to collect them, all right? So Wednesday, all of this has to be done, all right? This review is on my website. If you need to go back and look at it, that is perfectly fine. But it is, I will be looking at all this when I get back on Wednesday. Okay? If you have any questions, please shoot me an email or any concerns and we can go from there. Okay? Have a great Monday. If you have any questions, let me know.